Welcome to the Distant Curve Severe Weather Analysis for Ayers Rock, Sunday, February 22nd, 2026. Today we are examining atmospheric conditions across the Uluru region during the austral summer peak. If you find this analysis helpful, please like and subscribe to support continued severe weather analysis. Let's start with this morning's atmospheric sounding taken at 10 a.m. local time. We can see a fairly stable environmental profile with moderate moisture content across the lower levels. The temperature profile shows typical desert heating patterns with strong surface warmth. The dewpoint profile indicates relatively dry conditions aloft, which is characteristic of the interior Australian summer environment. There's a weak to moderate capping inversion visible in the mid-levels, which will play a critical role in determining afternoon convective potential. Overall, the morning environment shows limited instability, with relatively modest energy available for thunderstorm development. Now let's examine how this environment transforms through the afternoon hours as solar heating intensifies. We are looking at what happens when we apply the expected afternoon heating to the morning atmospheric profile. The key transformation we see is in the lower levels, where strong surface heating will generate increasing instability. The enhanced plot shows the potential parcel paths available through the afternoon period. We can observe that while some energy will be released as the afternoon cap breaks, the overall atmospheric structure remains relatively constrained compared to environments supporting widespread severe weather. The most significant change is concentrated in the boundary layer, where heating will create the strongest updraft potential. However, the stable mid and upper levels will continue to limit the vertical extent of convection. Examining the wind profile through the hodograph, we can see the directional and speed changes with height across the atmosphere. The hodograph trace shows relatively weak wind shear curvature, indicating limited directional change through the depth of the atmosphere. 0 to 6 km bulk shear remains modest, which constrains the potential for organized severe thunderstorm development. The low-level wind profile shows minimal 0 to 1 km shear, reducing microburst potential. Right mover and left mover vectors, where present, indicate the expected storm motion directions, but with suppressed wind shear, sustained organized storm structures are unlikely. The overall wind profile suggests that if storms do develop, they would be relatively disorganized and short-lived. From an operational perspective, prepositioning of emergency services for widespread wind damage is not indicated by these wind shear characteristics. Looking at the Bruntweishaler frequency profile, which measures atmospheric stability at different heights, we can see how layered stability varies through the depth of the atmosphere. The n-squared profile shows variable stability across different levels. Mid-level stability, particularly in the 2 to 5 km layer, appears moderate, which would typically limit downdraft intensity if storms were to develop. However, with the very low CAPE values forecasted, sustained downdrafts are unlikely to reach extreme intensities. The dry air in the subcloud layer and low-level environment, combined with weak instability aloft, suggests that microburst potential is minimal. The overall stability profile does not support the conditions necessary for extreme downdraft events. Large hail growth environment shows limited freezing level heights and weak vertical motion potential, so significant hail is not expected. The stability structure indicates that even if some thunderstorm activity manages to develop, the atmospheric environment is not conducive to severe manifestations. Moving forward to tomorrow morning, the ML model forecasts very limited instability across the region. Mixed layer CAPE is predicted to be near 0 joules per kilogram, with surface-based CAPE also near 0. Wind shear in the 0 to 6 km layer is forecast to be minimal at 0.0 meters per second. The lifting condensation level will be around 93 meters above ground level, indicating very dry conditions in the boundary layer. Both the supercell composite parameter and significant tornado parameter are essentially 0, indicating subconvective conditions. Storm mode is classified as subconvective due to insufficient CAPE for organized thunderstorm development. By tomorrow afternoon, the forecast continues to show suppressed convective potential. Mixed layer CAPE remains at 0 joules per kilogram with surface-based CAPE also at 0. Wind shear in the 0 to 6 km layer remains at 0.0 meters per second. The lifting condensation level is predicted at 144 meters above ground level. Significant tornado parameter and supercell composite parameter both remain at 0. The severe hail parameter is also 0, and ship index is 0. The lapse rate between 700 and 500 millibars is forecast at 49.9 degrees Celsius per kilometer. Storm mode is again subconvective due to insufficient CAPE for thunderstorm organization. Across both morning and afternoon tomorrow, we are seeing a pattern of very suppressed convective potential. Looking at the evolution of key parameters through the forecast period, we can track how mixed layer CAPE, wind shear, and helicity change throughout the day. The model output shows relatively weak and suppressed values across the entire forecast window. Mixed layer CAPE remains constrained, indicating limited energy available for storm organization. Wind shear remains minimal across the 0 to 6 kilometer layer, providing little directional wind variation to support supercell development. Helicity values remain low throughout the period, limiting the potential for rotating updrafts. The timing signal from the model suggests suppressed conditions persist through both the morning and afternoon forecast hours. These trends indicate that organized severe thunderstorms are unlikely to develop across the region during this period. In summary, atmospheric conditions across Ayers Rock on Sunday, February 22, 2026 show suppressed severe weather potential with limited instability and weak wind shear. Tomorrow's forecast continues this pattern of constrained convective potential. For the most detailed and up-to-date severe weather information, always consult the Bureau of Meteorology and stay informed through official weather alerts. This analysis is provided by Distant Curve Remote Area Telecommunications. If you found this helpful, please like and subscribe to support continued severe weather coverage for remote Australia.